Hi everyone, great to have you here. Today we are very excited to share with you what's new and what's next with Google BigQuery. My name is Neeraja Rentachintala. I lead the product management for BigQuery. Joining me as speakers today, Tomas, who is our VP of Engineering for BigQuery, and Fernando Croceri, who is the Director of Data Analytics and Applied AI at Mercado Libre, who is here to share with us their analytics and AI journey with BigQuery. We have an action-packed agenda, so let's get started. The next wave of data and analytics is agentic. This means moving beyond dashboards, reports, and human decision-making into autonomous agents that can independently reason and act. This is a game changer for customers because it allows you to boost productivity by automating the data lifecycle, figure out powerful, innovative user experiences, as well as fundamentally rethink the business processes. For agents to be truly autonomous, however, they need to be grounded in a world-class data foundation. Otherwise, they are hallucinating. And we believe the data platforms need to become the systems of action with evolution across 4 key pillars. First, they need to be open with all data, structured, unstructured, across clouds. Contextual, meaning curating and updating the business context from this data in real time. They need to be AI native for advanced reasoning, and agentic to power sophisticated agents. Notice the optimization loop at the bottom of the screen. In agentic era, the data platform isn't just a static destination, it is also a feedback loop where you can capture agent interactions and use these as real-time evaluations to continuously improve your agentic ecosystem. We have been evolving BigQuery over a decade from a data warehouse to become the primary engine for agentic era. We started with the foundations, serverless architecture built on Google's global infrastructure. We introduced streaming, we introduced machine learning, first time in the data warehouse. Then we expanded to other clouds, open formats, unstructured data. We added BI engine capabilities, scalable Python processing. In the last couple of years, we have added staggering AI innovations with native AI co-processing, vector embeddings, making all of this available through ADK and MCP toolkits, and most recently, the conversational analytics. And we are seeing tremendous traction for a lot of new use cases with BigQuery. For example, Gemini in BQ has seen over 30 times growth in the last year, and AI processing has seen 25 times growth, and vector searches has seen 10x growth with tens of billions of searches just in the last 6 months. And we are also seeing incredible outcomes for our customers. Palo Alto Networks, for example, is seeing 40% cost reduction while processing millions of security events per second. PayPal saw 2.5 to 10x better performance and 16 times better fresher data for their personalization. And Love saw 16 million incremental annualized revenue with their real-time visual search feature. Throughout these innovations, our product focus areas remain consistent. First, provide unparalleled performance and scale, building on our core serverless engine. Second, offer advanced analytics. Go beyond SQL to AI, search, graph, streaming, so that you don't have to spin up multiple systems or move the data around. BigQuery is the platform to do all of these use cases. And third, make all of these capabilities available on all your data. And finally, offer agentic experiences for all your users in the organization, business users and technical users. So let's dive into each of these areas and see what's new. As workloads diversify and become from human scale to agent scale, performance and price performance are non-negotiable. And we are really pushing the boundaries on what is possible here. With innovations like next-generation vectorized query execution, small query optimizations, history-based optimizations, we have improved BigQuery latency across a diverse set of workloads with specific focus on low latency, high concurrency dashboarding style applications. In just 1 year, BigQuery performance improved by 35%, reducing the query cost by 40%, across all industry standard benchmarks. And for dynamic workloads, data teams today face a challenge. Should we over-provision for SLAs or should we compromise on the performance for cost? With BigQuery's unique architecture to scale up and down instantly, now we are eliminating the trade-off. With the new fluid scaling, you get area under the curve billing, meaning you get charged only for the resources you used and on a per second basis. We have seen cost savings of more than 34% on an average in customer environments with fluid scaling. We are also up-leveling our observability. With the upgraded troubleshooting tools, you can instantly pinpoint performance bottlenecks, you can root cause them. You can also understand your cost drivers at a pretty granular level, project level, as well as job level. You can also manage BQ using AI-driven, natural language-based experiences. So this is all built to manage your workloads at scale on BigQuery. Now let's look into the advanced AI capabilities. With BigQuery AI, our goal is to make sure that AI is accessible for every data professional in the organization. We do it in 3 ways. The first thing is SQL native AI co-processing, meaning you can build models, train models in SQL, you can run inference right inside BigQuery without moving the data anywhere. Second, with our open ecosystem, we get you access to the frontier models like Gemini, Claude, Hugging Face, without managing any infrastructure. And with the integrated vector search, you have access to billion scale RAG use cases right inside BigQuery. We are today delighted to introduce the TimesFM capability in BigQuery inside Google Sheets. So TimesFM is a zero-shot forecasting model. It's a Google research model trained over 100 billion real-life data points. You can use it to forecast to any horizon using simple SQL. You can do anomaly detection. So all of these capabilities are now in Google Sheets at BigQuery scale. We're also launching a state-of-the-art transformer-based tabular foundation model for classification and regression on structured data. Very easy to use, in-context learning, simple SQL statements. This runs inside BigQuery, so supports massive scale. And in our internal benchmarks, we have seen this very efficient, better accuracy than a custom-trained XGBoost models. And as multimodal era accelerates, we are also evolving BigQuery as the foundation for unstructured data. Today, we are delighted to announce that ObjectRef data type is now generally available. With ObjectRef, you can represent structured data, unstructured data in the same table as separate columns. This makes it easy to join these data sets, do analytics, do AI processing, so you don't have to spin up separate pipelines for structured and unstructured data and then copy the data around. We're also bringing generative AI much more closer to your SQL native workflows with a set of managed AI functions. With AI.classify, you can automatically categorize large amounts of unstructured data. With AI AG, you can do semantic aggregation by summarizing topics across large amounts of unstructured data. And AIF is semantic conditional logic. So the idea is bring the power of, the reasoning power of LLMs directly to your SQL without you as a user having to know anything about the underlying models. So this is all simple SQL. And this kind of semantic reasoning doesn't need to be restricted to small data sets. Today we are announcing a breakthrough innovation. This is the optimized mode for AI functions. With this, you can run these AI functions at scale without having to have exploding costs of LLM tokens. So this is powered by distilled models. These are trained on the fly for your specific queries. And in internal benchmarks with AIF, AI Classify, we have seen token reduction up to 230 times compared to the row-by-row generative AI processing. We are also continuing to improve our vector search capabilities. We are bridging the data to AI gap with autonomous embedding generation. This means at the data ingestion time for the chosen columns, BigQuery can automatically generate the embeddings. This is now generally available. We're also expanding on our document processing capabilities. So getting the documents ready for GenAI traditionally is pretty complex. BigQuery already offers a general purpose function called ml.processDocument. We are further simplifying it with the AI.parseDocument. With this, you can have a BigQuery table. It can contain references to PDFs. You just run this function and you get the extracted chunks right in that BigQuery table. So extremely easy. And behind the scenes, we use Gemini, advanced Gemini layout parser. So it works for real life documents with charts and graphs and double column formats. We're also bringing together the vector search and full text search into a very easy to use hybrid search functionality. With hybrid search, BigQuery does semantic matching, keyword matching, and then re-ranks the results for maximum precision. This not only improves the accuracy, but also reduces costs because now you can combine vector search with text search for less frequently used columns. Uncovering complex relationships in data traditionally required traditional kind of slow and hard SQL joins. With BigQuery Graph, we are changing that. We are bringing graph capabilities directly to BigQuery without any ETL, without having to have a separate graph database. You can use graph query language, GQL, to traverse through the relationships, as well as do use cases like fraud detection, supply chain tracking, and network analysis. And you can also leverage some of the advanced features like AI processing, vector search, along with graph. For AI to solve complex multi-hop reasoning problems, we believe the business logic should be at the data platform layer. BigQuery Graph provides this foundation, and now we are introducing measures natively inside BigQuery Graph. These knowledge graphs ground AI agents such as conversational analytics, so they can do much more sophisticated why questions, why sales is low, why customer is churning through the multi-hop reasoning relations. And by having these measures and the entities, relationships, and the logic at the data platform layer, whether you are building AI agents or BI dashboards on BigQuery, they are grounded in a common governed reality. Now let's talk about how we are bringing all this performance, all these AI capabilities that I just talked about to all your data. We are investing in Lakehouse with BigQuery. So we are making Apache Iceberg as a native citizen inside BigQuery. Our strategy has 3 pillars. First, bring the best of BigQuery to make Apache Iceberg as the advanced enterprise-grade storage. Second, offer interoperability between BigQuery and open source engines. And finally, use Iceberg as the foundation to make BigQuery capabilities available on the data in other clouds. We have been making a lot of progress on our Lakehouse. Today, we are delighted to introduce the general availability of multi-statement transactions for Apache Iceberg with BigQuery. Data integrity is not negotiable, especially if you are doing financial updates, GDPR type of use cases. So with this capability, now you can build complex ETL pipelines. You can do multi-stage processing with full ACID consistency on Iceberg when using BigQuery. We also have the high throughput change data replication now generally available. So with this, you can stream data, inserts, updates, deletes directly into Iceberg. You don't have to spin up separate merge-based pipelines outside. Our goal is to make sure the transactional systems and the Lakehouse is in sync effortlessly when you are using BigQuery. We're also introducing full read-write interoperability for Apache Iceberg. This means that BigQuery can now read and write to the same data that is operated by other engines like Spark, Flink, or any Iceberg engine. And the underlying catalog, the Lakehouse runtime catalog, previously referred as Big Lake, supports multi-writer capabilities, meaning it can maintain the metadata consistency even though multiple engines are operating on the same data. As customers looking to embrace AI and agents, they often struggle to bring these capabilities to their data in other clouds. So traditional fixes, you move the data or you do high latency queries. This adds overhead, increases cost, especially it doesn't just work at scale. So today we are announcing cross-cloud lakehouse, bringing BigQuery performance and AI to the data in other clouds. By leveraging Iceberg REST Catalog Federation, cross-cloud interconnects, transparent caching, now BigQuery can deliver the performance and the TCO of native data warehouses directly on your data in AWS S3. We are making true cross-cloud capabilities a reality for enterprises. The Open Cross-Cloud Foundation also powers zero-copy use cases. BigQuery now can seamlessly query the data that is there in SAP, Salesforce, without doing any ETL, and you can join it with the data that is there in BigQuery. With that, I would like to welcome Fernando to the stage to talk to us about their transformation with AI using BigQuery.
Thank you. Hello, everyone. I'm Fernando Croceri. I'm Director of Data and AI Capabilities at Mercado Libre. And I will talk about how we turn a data warehouse into an AI-powered decision engine. For those who don't know, Mercado Libre is the largest company in Latin America. It was founded in 1999, and our mission is to democratize e-commerce and financial services across the region. For the past 26 years, we've been operating in 18 countries, and to give some context of the company, in the fourth quarter of 2025, we reached nearly $20 billion in GMV, growing more than 30% year over year, while serving 83 million unique buyers and 78 million monthly active users. To translate into 95 purchases per second and 566 financial transactions per second. Every one of those transactions has to deliver the right product at the right time to the right person. And that's what exactly our data platform needs to deliver. Our ecosystem is one of the largest in Google Cloud. We store more than 354 petabytes in our raw layer, and every single day we process millions of user interactions. In total, we manage more than 100,000 tables, and our users run more than 1,000 queries per second. But why is this important? When we migrated to BigQuery 6 years ago, we were a company of 10,000 employees. In 6 years, we grew 11x. We are 125,000 employees at this moment. And to keep up with that growth, we made 3 key decisions. First, we built our own data platform where users can develop and catalog data. Second, we adopted a data mesh approach to decentralize data production without turning the platform on a bottleneck to our team or the platform. And third, when GenAI arrived, we built our own GenAI ecosystem that from the beginning governs and flows information with GenAI providers and allows us fast integrations with industry models. In the middle of that increasingly complex ecosystem, we doubled down on BigQuery over the last 6 years, and we continuously evolve our platform and our capabilities. So, as you can see, the business grew hand in hand with the complexities, and BigQuery was there to help us to simplify and deliver value. We developed many tech assets along the way, but here we will focus in the foundational ones. On the left side, you have data mesh and BigQuery as a service, the ones that bring the information into BigQuery. On the right side, you have the data catalog and the Looker semantic layer, the ones that let us govern and serve the information to our users and agents. In this ecosystem, information flows in and out BigQuery. So let's put BigQuery in the center. This is no longer a simple warehouse. It's a full analytical platform while with a lot of capabilities, where we have approximately 700 teams environment running in data mesh and using new capabilities of BigQuery fully available for them. We empower to provision themselves the infrastructure that they need. So the message here is we have our own platform fully integrated with BigQuery, where the different tiers of information live together and embed in an analytical ecosystem with AI and machine learning capabilities available for them. But how this is translated into business value? We have many applications running across Mercado Libre, digital commerce, customer engagement, marketing, data and advanced analytics, and of course, in IT. And these applications are crucial for boosting our productivity, reducing business complexities, and of course, generate value. If we talk specifically about e-commerce, we use BigQuery, vector search, and machine learning capabilities for main 3 use cases. The first one is product matching for main use cases. Product matching, automated pricing, and user recommendations. We have achieved strong metrics, but the most important takeaway here is how quickly these technologies help teams to develop and iterate and experiment with new models at a low cost. To support these solutions, of course, we index millions of data points across items, products, navigation behavior, purchases, catalog documents, and driving a significant improvement in our user experience. Ultimately, the platform ability to accelerate experimentation and simplify the execution was made those results possible for us. Moving from business use cases to our inside company applications, we have heavily invested in AI for our own internal productivity. We developed our own conversational analytics solution. Our users access to different layers depending on their needs. The agents can be accessed through different entry points, and we let the users to choose the option that best fits for the tools and technical expertise. For example, they can use coding CLIs like Gemini CLI or Cloud Code, or access it through Fury, that is our own development platform. Thanks to our Looker semantic layer, we serve information in a curated environment. We achieve a 90% accuracy on model data. Users can ask for insights, on-demand calculations, and more. Of course, for open set questions, we don't have the same accuracy. We have 70% accuracy, but we keep improving it every day because the impact of this type of technology can be significant in our teams. So building this, it wasn't easy. I want to share the 4 lessons that we learned in the process. First, you have to choose wisely. When we bet on BigQuery, we did it on 2 pillars. First, scalability, and second, the ability to execute. We trust in GCP that will improve the product over the time. That, I think, was a wise choice. The second one is to document your business knowledge. It's one of the more important things in this era. If we had documented everything over the last years, I think that we would have reached better results at this point. The third one is choosing the right tool for the semantic layer. It's not easy. It's not an easy decision. So we trust in Looker some years ago, and we are having very good results with serving Looker as a semantic layer and accessed by agents. And the last one, optimize your queries and govern cost. If you don't govern at the right time, BigQuery in a petabyte scale can be expensive. Of course, it scales a lot, but you keep an eye on it, on your cost, so you can keep your CFO happy. So, to conclude, now more than ever, in this Gen AI era, where you can call it data science, machine learning, or AI, the hardest part of building has never been AI. Having a single data platform with curated information powered by AI capabilities can make all the difference. Tomas. Fernando.
All right, thank you, Fernando. So let me talk about what do we have new with agents and hopefully how we can simplify building agents for Mercado Libre and our customers. Right? So as we think about agents, few trends which are happening. So first, it's actually becoming possible to deep dive into business questions and understand the why behind data. Second trend that we're observing, agents are appearing in every single tool that you're working in, be it a BI tool or your data engineering tool. And then finally, agents are transitioning to become your coworkers, right? Working alongside with you, potentially investigating why business metric changed, or operating and creating pipelines on your behalf. So as we think about agents, we want to make sure that you have flexibility to choose a starting point. You can start with agents that we built, such as conversational analytics or data engineering. You can use its APIs to embed in your applications, or you can choose to use MCP and the tools that we provide, right? Using Google Agent Development Kit or third-party open source ecosystems for agents. Or after all, you can use also our APIs directly. So let me mention a few things that we have in our Google Developer Console for data developers. So first, a data engineering agent you can use to build data form-driven pipelines. Simplifies your data engineering tasks, really accelerates it. Second one is the data science agent available in the notebooks with BigQuery. You can generate your notebooks, you can do some feature engineering, create machine learning models, and truly like get faster to get data science tasks done. And the last one is BigQuery Assistant. It works alongside with you with your SQL editor or your admin tasks, right there on the right-hand panel, and you can ask questions and help you write SQL and administer BigQuery. So speaking of data science, we invested quite a bit recently on a few features. So with AI assistants to go and edit notebooks and Python code, we added SQL cells and Python interop. We borrowed some visualization from Data Studio to help with the notebooks, added scheduling, and also great Git integration, right? So really we invested quite a bit into data science as well. So then once you develop a notebook, usually you want to go share it, and often you want to share it with your business users. So the feature that we are announcing today is Collab Data Apps. So you create notebook in BigQuery Studio, and you can create a Python-based application with rich visualizations, and you can deploy it to Data Studio right where your business users are alongside with all the reports and dashboards. But let me talk more about conversational analytics, because I think this is where we see the greatest opportunity to really open up access to data for all the business users. So really we want to enable you to go from manually created dashboards that you have to curate for every single question that one wants to ask. Really want to go to agents that you can create, and at most, you'll curate the data that those agents should use. So I'm happy to announce conversational analytics in BigQuery is going GA. We're enabling you to create a high accuracy agents. You can configure it with specific data, such as tables or graphs, some additional instructions if you need to, and then you can distribute them to your business users. It is also available as API, so you can embed it in your applications, or if you need a different user experience, you can do that as well. So one thing that we wanted to do when developing conversational analytics for BigQuery, we wanted to make sure that we can take advantage of all the advanced capabilities that Neeraja was talking about. So first, you can ground those agents with BigQuery graphs, so that those agents know the entities and the relationships, what exactly columns to join, or the measures to compute the business metrics. Second, ML and AI is also deeply integrated. So for example, you can do time series forecasting or contribution analysis, or in general, additional business-oriented tasks right there in the conversational analytics. And then last, we also made it multimodal. So you can use AI to process unstructured data, semi-structured data alongside with your structured data. You can do tasks like sentiment analysis, content summarization, disambiguation, and similar tasks. And if there are embeddings that you generated, then they'll automatically take advantage of those as well. So how do you start? Well, you go to BigQuery Studio to develop those agents. You define them there. You point them to tables and other data sources. And then if you're a data developer, then of course you can use them right there. You can go analyze. Now, if you want to share those agents with business users, then you publish them to Data Studio, formerly known as Looker Studio. And then lastly, Tomas spoke a lot about Gemini Enterprise today at the keynote. So you can take the agents that you create with conversational analytics in BigQuery, and you can publish them to Gemini Enterprise. So Gemini Enterprise becomes a single place where all your business users can interact, not just with data agents, but every single agent backing your business. So we're not stopping there. Actually, if we look forward, we're also working on what we call agentic workflows. So really, we want to enhance those conversational analytics agents to be able to do things proactively in the background on your behalf, such as monitor business metrics, understand and build personalized business context over time. And also, you can send them off to do a deep dive or research to come back with their answers, and they can work in the background. So let me do a demo of some of the innovations that we announced today. The scenario that I want you to imagine is, imagine that we're working with a frozen yogurt machine manufacturer, and we're facing a recall. One of the materials in those frozen yogurt machines is actually defective, and I need to figure out the impact of this recall. So I have things like parts, materials, products, which are the machines which are sold, and my customers, right? So the challenge is that some of the part and material information is actually in PDFs. So it's sitting in unstructured data. My customer data and transaction data is actually in BigQuery. So somehow I need to bring this all together and get the answers. So let me show you how. All right. If we can switch to the laptop, please. All right. So what we're going to do is to build a knowledge graph with BigQuery. We'll bring the structured and unstructured data together, and then we'll use conversational analytics to analyze it all. So now, in the interest of time, we've pre-run, but I'll walk you through how to do it. All right. So first thing, my PDFs are sitting on Google Cloud Storage. I'm going to create an object table to just be able to reference to them, right? So I do that. Step number 2, I want to go extract content out of those PDFs. So I'm going to use a document processor from a Cloud AI team. So I create that. I register it also as a model. And then I'm going to do a text extraction, right? Now the document content that will come back from extraction is actually deeply nested complex structure. So next thing that we'll do, we're going to go flatten it so we can process it later, right? So I'm going to go create additional table on top of that extracted structure, right? So now we're ready actually to analyze the document content with a Gemini model. This is the most actually exciting part. So what we're going to ask the model to do is to do essentially entity extraction from those PDFs. I want to tell it to identify parts, materials, products that we refer to, and also their relationships, right? So we've defined the prompt essentially telling the model to go look for it, right? And back, we get a structure, right? And you can see it right here. So entities and their relationships, essentially in a table that comes back, right? So this came back in a table. And the next thing I'm going to do is to actually then take this generic entity and relationship table extracted, and I'll create specific tables for my nodes and edges in that graph, right? So I'll create a parts table, I'll create materials table, and I'll create the relationships, right? So I'm going to go do that next. So I did that with a material, I did with product and parts and material relationships, and I'm also bringing in the product sale information that I already had in BigQuery, right? So what I'm doing is I'm creating a single structured data in BigQuery, and the next step I'll do, I'll create a property graph over it to connect it all together. So scrolling through quickly. So this is my graph definition. I have a customer node, I have my products, I have my parts, I have materials, and then I have purchase orders, parts in the product, and materials making up parts, right? So this is my graph definition pointing to those tables that I've created. And then, of course, when I can go and visualize the graph in the notebooks themselves, there is actually a rich visualization that we added. So the question I want to answer, given I'm facing material recall, in this case it's a fiberglass that I want to figure out the impact, I'm just going to go scroll straight to that specific question where I used the graph query language, and I was able to identify, this is the material node, the part, and the 7 customers which are impacted. So remember this 7 customers, right? So this was the role of a data science and data engineer, essentially kind of bringing the data together with giving you tools to process unstructured data, extract structure out of it, and then combine it all into a way for agents to reason. So let me show you how would a business user answer the questions. So next thing I've done is I created an agent for conversational analytics in BigQuery. And the only thing I did, actually, I pointed this to this graph that I've created before, right? And you can add additional information or context, but generally, for the most common scenarios, actually, it's not necessary. That's the only thing that you need to do. And then I'm going to go and ask the business questions, right? So now I'm a business user trying to figure out the impact of that recall. So first question I ask is, show me all the customers impacted by this fiberglass recall, and then tell me also about their purchase history. And then the agent went and figured this out. So if I expand actually in BigQuery Studio, you can also see the SQL or graph query language that is generated. You can see right there it actually generated the correct graph query language. And then it went and visualized, right? So now, of course, like a business user doesn't have to go look at SQL, but as a developer, you definitely can, right? So now the next interesting question is, generally when I'm facing a recall, I want to be able to support those customers, right? And the way I think in my business, I want to have essentially a budget or allowance, how much I'm willing to spend supporting those customers. Now, this support allowance question is actually a very ambiguous question for a large language model to answer. So what we've done, we actually created a metric, a measure, on top of that graph that Neeraja was talking about, right? And essentially, we defined it as part of a graph definition. So when I ask this question, the agent only has to refer to the computation or the formula, right? It doesn't have to go invent what it is, right? So let me show you how it exactly looks, right? There's a graph expand function, which essentially flattens the graph for BI-like processing. And we simply went ahead and we referred to the metric itself, right, as a support allowance. And that's the only thing that the agent had to do, right? And when it came back with an answer of those are the customers and their support allowances and so on, right? But that's not everything. I think the other interesting task that business users want to do is to figure out what's going to happen in the future. So the next question one would ask, like, actually, what would be the revenue? Had I not faced this recall, what would be the revenue from all those customers, right? So now it's actually a time series prediction question, which conversational analytics agent in BigQuery is able to answer. Why? Because it's using the times of a model that Neeraja was talking about to actually do a forecasting on your behalf, right? And if I expand and I want to peek into SQL, I can actually see it right there, right? Essentially, we're calling it time series foundation model, right? And doing forecasting on what happened before. All right, so there you have it. We brought together unstructured data, structured data, put it all into a graph for highly accurate conversational analytics agents, relationships, and the actual measures to compute business metrics. And then we enable your business users to answer questions, right? All right. So now let me talk a little bit about what we're doing with the agent development itself. So now if you want to build your own agent, we have also a few capabilities, right? We actually offer 3 major integration points for building your own agents with BigQuery. So first is the agent development kit integration, where we actually provide built-in tools such as finding tables, listing table information, executing SQL, doing some machine learning forecasting. We package it all up into a BigQuery toolset. So really all you need to do is to reference that toolset in your agent, and you're ready to go. The next investment that we've done is what we call BigQuery Remote MCP Server. So it's a fully managed MCP server run over in our server side. It's actually also optimized for enterprise security. You get to control which projects are eligible for MCP tool calls, and you also get additional integration with Model Armor, right? Now, if you want the ultimate customization, then there is also an open source MCP toolbox for databases. This toolbox runs MCP servers locally, generally, where you run your agent or your IDE, and you get the ultimate customization where you can actually, in fact, go as far as take your SQL objects, your queries, and turn them into MCP tools for agents to use. So actually, we've seen quite a bit of growth on all those MCP tools and agent development kit adoption as well. So now, as we were developing our own first-party agents, be it conversational agents or data engineering agents, one thing that we realized is actually worthwhile to decompose those agents into tools and skills so that we can go reuse those tools and skills across multiple scenarios, right? So we already spoke about MCP tools, be it through agent development kit or MCP servers. So the next thing that we wanted to do is to attack the skills. So I'm happy to announce that we are previewing what we call Google Cloud Data Agent Kit. So essentially what we've done, we took most of those skills that we developed for data engineering agent or data science agent, and we packaged and open sourced them as skills, right? So you can use them in all common agentic ecosystems, be it Gemini CLI, be it Claude Code or OpenAI Codex, right, where we've tested compatibility with all of them, right? And you can start actually now focusing on intent for your data engineering task or data science task. You simply tell the agents in those ecosystems what to do. They'll use the skills. They'll know how to build pipelines. They'll know how to do data science on top of your data in BigQuery or the rest of the GCP, right? And then the last bit there, we also wanted to make sure that you have a complete user agentic experience. So we also, in this data agent kit, shipping an IDE extension for VS Code and also other VS Code-based IDEs such as Croceri and others. So go check this out, and you'll actually be pretty amazed on what those agents are capable of doing. So now, as you build your agents, one additional task that you want to think about is actually how all those agents are doing in production. So for that, we're providing BigQuery Agent Analytics, where we're making it easy for you to ingest the agent telemetry into BigQuery. And the agent telemetry can be sourced from Agent Development Kit, can be from LangChain. So if you're running, for example, Agent Engine as part of our Gemini Enterprise Agent platform, you can actually configure those agents to go emit the telemetry into BigQuery. So next thing that you can do, you can use conversational analytics, or you can use any other favorite BI or visualization tool, go and understand how well your agents are doing, right? So really easy to just turn it on. Right? So that was the quick journey for our recent innovation in BigQuery. There is actually quite a bit that we couldn't fit into this talk, so we wanted to give you an overview. So go check out those additional sessions, be it on agent development, on Lakehouse, on graph, on data science. There are many, many more sessions that I'd encourage you to attend. And then last but not least, there is also additional webinar that we're hosting in May to talk about our H2 26 roadmap. So please check it out and sign up as well. Okay. All right. Well, thank you for joining us for this session. Yeah.